So at one point in your life, you might wonder what happens if you have 5 pigeons and only 4 holes. The result might surprise you. No, actually it won't. Oh, what's up YouTube? Thank you for spending a little bit of your time with me today. Alright, today we're going to be talking about Pigeonhole Principle. At the end of this video, you know what Pigeonhole Principle is, and more importantly, how to use it. So let's go. Pigeonhole Principle is a statement that says if you have some number of pigeons, you have some number of holes, and it just happens so that the number of pigeons is more than holes. And if you try to assign pigeons to hole in some way, then what happens is there will be at least one hole that contains more than 2 pigeons. Well, of course it's true because we don't have enough holes. So this statement is pretty easy to understand why this is true. The statement is not hard to understand, but applying the statement to actual problem might be a little tricky. Step 1, you need to say what are your pigeons. Usually there will be objects that you're interested in the problem. So the easy way to figure out is read the problem, and if the problem says something like prove that there are at least 2 things that satisfy some property, blah blah blah, those things will be your pigeons. Step 2, construct holes and describe how you assign pigeons to holes. Usually this is a step that is not so obvious because holes will be something that you need to think about, but here's a trick how to construct holes. You want to construct holes and the rules so that 2 pigeons in the same hole would imply the thing that you want to prove. For example, if you want to prove that there are 2 things that have the same color, you need to make sure that when you construct holes, you put things of the same color in the same hole. Step 3 is actually pretty easy. You just need to conclude that we have some number of pigeons that more than holes by Pigeonhole Principle. You can have 2 pigeons that in the same hole, and therefore the property that you want to prove will be true. Alright, with that in mind, let's look at one example. Alright, so here's the problem. So you have number from 1 to 20 and somebody come in and select random 11 numbers for you. So you don't have control over those 11 numbers, but you want to show that no matter how that guy select 11 numbers among these 20, you can select 2 numbers out of these 11 so that 2 numbers sum up to 21. Alright, so before actually applying Pigeonhole Principle to this problem, let's think about this a little bit why this is true. So let's try to disprove the statement, meaning let's try to come up with the set of 11 numbers so that no 2 sum up to 21. We want to pick 11 numbers so that no 2 of those 11 numbers sum up to 21. So let's say that the first number that we pick is 1. Then what happens is you cannot pick 20 because once you pick 20, no matter how you pick the rest, 1 and 20 would sum up to 21, which is precisely what you do not want. So the fact that you pick 1 means you cannot pick 20. But that's okay, right? We just lose one choice of number, we still have a lot more to go. So let's say we pick 2, which is still okay because 1 and 2 are in our set. 1 plus 2 is 3, which is not 21, it's fine. But once we pick 2, we cannot pick 19 because 2 and 19 sum up to 21. If you keep using this argument, eventually you're going to get a number from 1 to 10. And there's no way to pick 11 number because no matter what you pick as your 11 number, that 11 number will add to one of these numbers to become 21. With that, it's pretty convincing that if you pick 11 number, there will guarantee to be 2 numbers that add up to 21. But that's just an idea. Never use that as your actual proof. How do you know if you pick 10 elements other way, it also fails? Thus, the better way to solve this problem is to use Pigeonhole Principle. Alright, so first thing first, we ask what are pigeons, and as I say in the problem, it says among 11 numbers, prove that there are 2 numbers such that something happened. So those 11 numbers are pigeons. Next up is the hole. You want to construct hole so that if you put 2 numbers in the same hole, 2 would add up to be 21. That's easy. The first hole will be just a hole that you can put 1 and 20 in. The second hole would be the hole that you put 2 and 19. So on and so forth until the last one is the hole that you put 10 and 11 in. And last but not least is our conclusion. We say that there are 11 pigeons, but we only have 10 holes. By pigeonhole principle, there will be two numbers that fall into the same hole. And thus, those two will sum up to 21, which is exactly what we want to prove. Right, so that's all I want to talk about today. I hope this example illustrates the power of pigeonhole principle to you and make you understand pigeonhole principle a little more. And if you have any questions, please comment down below. I'll make sure I answer every single question of every one of you. And if you haven't already, please consider subscribing. I think it's right here, so that you will not miss my next video. But for today, thank you for watching. My name is Kwang and you're watching N Choose K. Peace.